Hello, my dear students. Welcome back to Manju's Maxtopia. I think you are seeing my videos and hope you can understand a lot. If you have any doubts, you can click through my WhatsApp number. Okay. So today we are going to learn about the chapter polynomial. This is second chapter of Cbse 10th standard. Okay. You have already learned about what is polynomial and all, and how to find the roots or how to find zeros. But still, I will explain. What do you mean by a polynomial? A polynomial can be expressed as the sum of terms. That means here we are having number of polynomials are right. So here 2x plus 3 is a polynomial. Then x square plus 5x plus 6 again it's a polynomial. Or 3x cube plus 2x square plus 5x plus 4 is a polynomial. So all these are polynomials, but different types of polynomials. Okay. So depending upon the degree, we can call it as linear, quadratic, cubic polynomial. Okay. Here, degree, that means what is the power of x? Here the power of x is 1. So we can call it as linear polynomial. Okay. Linear polynomial. Then obviously, we can see that what is the power here? Here the power is 2. So we can call it as quadratic equation. You have learned what is quadratic equation and all. So quadratic polynomial. So our basic form is, basic form ax square plus bx plus c. We know what is quadratic equation. So just like that. So this is quadratic polynomial. Then again, here the power is 3. So normally we can call it as cubic polynomial. Okay, here the power is 3. Degree is 3. Not power, the degree. We can call it polynomial. Always we can tell it as degree, not the power. So here the degree is 3. So we can call it as cubic polynomial. The basic form is ax cube plus bx square plus cx plus d. You just listen here. Here the degree is decreasing by 1. Okay. So we know types of polynomial now. Now, first of all, we have to learn linear polynomial or how to find the zero of the linear polynomial. We just listen 2x plus 3. 0 means here I can name it as px is 2x plus 3. And 0 means if px is equal to 0, that means 2x plus 3 is equal to 0. Here x is equal to 3. It goes to that side, that becomes minus 3. 2x is equal to minus 3. So x is equal to minus 3 by 2. The linear polynomial general equation is ax plus b. So what is x here? So x is equal to b. Go to that side, it will become minus b. So x is equal to minus b by a. This is the zeros of a, not zeros, zero of a, or root. We can call it as root also. Root of a linear polynomial. You just listen. 2x plus 3. So this 2 is a and this b is 3. So what is our 0? X is equal to minus b by a. 0 means when which value will give the resultant polynomial will be 0. That means if we are giving for the value of x is equal to minus 3 by 2, the value of this polynomial will be 0. Just look at 2 into minus 3 by 2 plus 3 is equal to, this 2 and 2 cut, so minus 3 plus 3 is equal to 0. That is called a 0. For what value of x this polynomial becomes 0, that is called a 0 of a polynomial. Okay, listen. So what is the 0 of linear polynomial? Here x is equal to minus b. Clear? Then now we can go to the 0 of quadratic polynomial. How to find out the 0 of quadratic and cubic polynomial? Okay. I think you have cleared the concept of linear polynomial and how to find out the 0 of a linear polynomial. Okay. Now we are going to quadratic polynomial. You have learned the quadratic equation and how to find out the roots and all. But the case is different for the quadratic polynomial. Okay, by factorization method, we are finding the roots or zeros of the polynomial here. Let's listen here. I'm just going to write one part quadratic polynomial. You just look. You know how to factorize it also. X square minus 3x minus 4. This is a quadratic polynomial. And what are the zeros? That means for what value of x the polynomial's value becomes 0. That is called a zeros. So here, how to find out the roots? We know by factorization. So how we will find out the factorization? Then just listen. We have to add, we have to get the sum by adding the two numbers minus 3, and we multiply the two numbers. We have to get the product minus 4. So my sum is minus 3 here and my product is minus 4. So what are the numbers? So I'll write minus 4 and plus 1. Minus 4 plus 1. The sum is minus 3. Clear? So minus 4 into 1. The product is minus 4. So how we can factorize it? X square minus. So this minus 3x I can be factorized as minus 4x plus x. Clear? Minus 3x I'm just writing like this. Minus 4x plus x. The resultant will be minus 3x. Minus 4. Now you just here x is common for these two terms. So I'm just taking outside x. So x into x minus 4. Again here 1 into x minus 4. Okay. For easiness I'm just writing 1. Then x minus 4 is common here. So x minus 4. Here the balance is x and here the balance is 1. So what are the zeros here? Either x is equal to 4 or x is equal to minus 1 are the zeros of this polynomial. Okay. So we just substitute the value here. If you put the value 4, then 16 minus 3 into 4 minus 4 is equal to, you just listen, 16 minus 16 is equal to 0. So x is equal to 4 is a 0 of this polynomial. Then you take another value, x is equal to minus 1. So here 1 minus 1 the whole square is equal to 1. Then minus 3 into minus 1. Again minus 4. Here you have minus 1. Minus 3 into minus 1 plus 3 minus 4. Again it will become 0. So we can say that x is equal to 4 or x is equal to minus 1 are the zeros of this polynomial. So obviously it is clear that when the degree is 2, the number of zeros will be 2. When the degree is 3, the number of zeros will be 3. Okay, we can go to some other examples also. We can go. Now we are going to plot the zeros of this linear polynomial in graph. Okay, so for drawing a graph, you need x and y axis. Here my unit is 1, so I have 1, 2, 3 here, then up to 7 here. So this is my x-axis. You know the equation of the x-axis, that is the y is always 0. That means anywhere for any point in x-axis, the y value is 0. And here y-axis x is equal to 0. That means any point in this y-axis, the x value becomes 0. Okay, now we can plot. Here when minus 2, when the x is minus 2, then what will be my y value? Y is equal to 2 into minus 2 plus 3. That is minus 4 plus 3 is equal to minus 1. Okay, so I'm just plotting here minus 2. And when x is minus 2, my value becomes minus 1 here. When x is 2, that means here 2 into 2, 4, 4 plus 3, 7. So the value will be 7. I'll plot here. X is equal to 2 here. Okay. So when x is equal to 0, 2 into 0 plus 3, the value will be 3. So I'm plotting 3 here. When x is equal to 0, 0, 3 here. And when x is equal to minus 3 by 2, that means really that is the zero of this polynomial. That means for which value of x the value of the polynomial becomes 0. Here it is minus 3 by 2. You just listen. 2 into minus 3 by 2. So this 2 and 2 we can cut. So minus 3 plus 3 is equal to 0. So for the value of x, that is minus 3 by 2, the zero of the value of the polynomial becomes 0. That is called the zeros of the polynomial. So I'm just plotting that point also. Minus 3 by 2. That means minus 3 by 2 means in between the value of 1 and 2. That's 1.5, right? Minus 3 by 2. So here in between minus 1 and 2. So it will come here. So the value, when x will be minus 3 by 2, the value of y will be 0. Clear? I already told that any point in x-axis, the value of y becomes 0. So we can plot here minus 1 by 2. So this come here. So my marker is finished. So I'll take another marker. Okay. So my value will be like this. I told you the minus 3 by 2 it will come here. So now we can draw the graph. It will be like this by connecting all these points. So it will be like this. So by graphically, how we know the zero of the polynomial? At x-axis, on which point it intersects. That means the graph intersects at which point on x-axis is called the zero of the polynomial. Clear? Got it? I think you have cleared the concept. So the graph at which point on x-axis it intersects is called zero of the polynomial. Okay. We are going to draw a graph. We are going to zeros of the second degree polynomial on graph. Okay. So you just listen how it. So we need to know. So we know how to. We need to get the value of x and y to plot the graph. So you just when the value of x is -2, the value of y becomes 6. That means -2 the whole square. Y is equal to -2 the whole square minus 3 into -2 minus 4. That means 4 minus 3 into -2 is 6. Then it becomes -4 is 4 and 4 cuts, so the value is 6. Okay, similarly, when we put the value of -1 here, we are getting the y 0, and when we are putting x 0, we get -4, 1, we get -6. You have to do all these things, okay, like this. It's not, when it is 2, it will be -6, and this 3, it will be 4. So it will, when x becomes 4, the value of y is 0. Now we can plot these points, okay. When -2, the value will be 6 here, okay. When -1, the value will be here. I already told you for any value of, for any point in x-axis, the value of y will be 0. So minus is 0, here -1 0, that the -1 is here. The value, the point in x-axis. So the value of y will be obviously 0. Then 1, it is -6. Then it is -1. 1 means it is -6 here. Okay. Then 2 also, it is -6 here. Okay, you just check it. Y is equal to 1. Then 1 minus 3 into 1 minus 4. That is 1 minus 7 is equal to -6. Then 2. When you put the value as 2, then 2 square, that is 4 minus 3 into 2, that is 6 minus 4. 6 minus 4, 10. 10 minus 4 is equal to, again it is 6. Okay, -6. So when we put the value 1, 2, the both value will be -6. When we put 3, the value will be 4 here. And when we put 4, the value will be 0 here. Now our graph will be like this. We can join all these points like this. Here no point on, here 2 points. Now 4, when the value x is x point 4 on x-axis, so we know that the value of y will be 0. So we can join like this. Then 3, when we put 3, it's 4. Now we can put another point also. When we put 5, then what will be the value? 5. Then the value will be, when you put 3, the value will be 3. When you just put the value of 3 also, then what will be? Y is equal to, you just check it, okay. You put the value, y is equal to 3 square minus 3 into 3 minus 4. That is 9 minus 9 minus 4. That is 9 minus 30. That is again 9 minus 4. So when we put the value as 3, then the value becomes here. This -4. I'm plotting the point here. So the graph will be like this, okay, and so on. So clearly, at which points the graph is intersecting at x-axis? On which points? Here the x is -1 and the x is 4. So the value will become, y value becomes 0. So these 2 points, the value of -1 and 4, the graph meet intersect at x-axis, okay. So the intersecting points at x-axis are called actually the zeros of the polynomial. Clear? Now I think the concept is clear. Zeros of the polynomial, that means the point at which the graph intersects on x-axis is called zeros of the polynomial. Okay. So we can easily identify the zeros of the polynomial by giving the graph also. Okay, from the graph also we can identify what are the zeros of the polynomial. Now we can go through the cubic polynomial also, how to draw the graph and all. Okay. Here is another example of a quadratic polynomial 3x square plus 5x minus 2. Now we can check how the coefficient of the polynomial is related with the zeros of the polynomial. Okay. So here uh, alpha plus beta, I am directly taking the from the equation. So generally we can see that ax square plus bx plus c is the quadratic polynomial. So here what is a is equal to 3, that means the coefficient of x square. And here what is b is the coefficient of x, that is 5. And here what is c, that is minus 2, clear? So if we are taking it from the directly from the polynomial, what we will get, that means suppose alpha and beta are the real roots here. So alpha plus beta is equal to, we have already learned from the equation, minus b by a. That means here b is 5, that is I am putting minus 5 here, minus b 5 by 3 is my alpha plus beta. That means sum of the roots. And what is alpha beta here? So again we know that c by a, because we proved from. So c by a is the product of the roots. So what is c here? Minus 2 by 3 is my product. Now we are going to check by actually finding out the real roots, real zeros here. Okay. So let me check what is the real zeros here. So here we know that, I'm just rubbing this. Here what is our alpha plus beta? Alpha plus beta is equal to minus 5 by 3, and alpha beta is equal to minus 2 by 3. Okay, let it be here. So we are going to find out the zeros here. 3x plus 5 minus 2. How will we find out the zeros? Because if x square is having the coefficient, then we have to multiply this coefficient with the constant c. That means minus 6 here. So when my zeros are multiplying, I have to get minus 6. So which are the two numbers? When we multiply, I have to get minus 6, and by adding, I have to get 5. Which are the two numbers? By multiplying, I have to get minus 6, and by adding, I have to get 5. So I'm just putting here plus 6 and minus 1. You just look at plus 6 and minus 1. 6 into minus 1. So minus 6. So plus 6 and minus 1 plus 5. So clear? So I can write it as 3x square. Now I'm just splitting this 5x as 6x minus 6 minus 2. This is the way to find out the zeros by factorization. Now 3x is common in these two terms. So 3x I am taking outside. So x plus 2 here, and here minus I am taking outside because I have to get the x plus 2 as common. So I am taking this minus sign common. So x plus 2 here also. Okay. So, what are my now? What are the real factors? So here x plus 2 again common. I am taking outside. So 3x minus 1 are the real zeros of my quadratic polynomial. So here either x plus 2 is equal to 0. That means x is equal to minus 2. Or 3x minus 1 is equal to 0. That means 3x is equal to 1, or x is equal to 1 by 3. Now these are the real alpha and beta of my quadratic polynomial by factorization method. Okay. Now we can check it by equation it is correct or not. Okay. So minus 2 is equal to my alpha here, and 1 by 3 is equal to beta here. Okay. So now check it. Alpha plus beta, what it is. Using by equation we get minus 5 by 3. So here minus 2 plus 1 by 3. So minus 2. Here 3 is the LCM. So 2 into 3 is minus 6 plus 1 by 3. That is minus 5 by 3. Clear? Minus 5 by 3 clear? Minus 5 by 3. Okay. So these two are same. And alpha beta is equal to minus 2 into 1 by 3. That minus 2 by 3. So clear? This is also correct. This one is also correct. So this is the relation between the zeros and the coefficient of the quadratic polynomial. Clear? Now we can go through another equation also. Then it will be more clear for you. Okay. So another equation is, now any quadratic polynomial you can take it like this: x square plus 7x plus 10. Okay, by equation what we get? Alpha plus beta is equal to, here ax square plus bx plus c is my quadratic polynomial. So a is equal to 1, b is equal to 7, and c is equal to 1 here. Okay, so what is alpha plus beta? We know that minus b by a is alpha by beta, alpha plus beta. So what is it? So minus 7. Clear? Then alpha beta what it will be? So c by a, that is c is 10 here. 10 by 1 is equal to 10. Okay. By finding the real zeros, we can check it. X square plus 7x plus 10. So 1 into 10, 10. Okay. So what we have to get? By multiplying, we have to get 5, and by adding, we have to get 7. Which are the two numbers? I'm taking 5 and 2 here. So x square plus 5 into 2, 10. 5 plus 2, 7. Clear? So 7x, I'm just factorizing. 7 splitting the term 7x for the adjustment. So 5x plus 2x plus 10. So here I'm taking x outside, so x plus 5 is the term. Here I'm taking 2 outside, so x plus 5 is the term here. So x plus 5 both are common, so I'm taking outside x plus 5, so x plus 2. So what are the real roots here? X minus 5 and x minus 2 are the real zeros here. So now you just take alpha plus beta, that is minus 5 minus 2 minus 7, correct. Then alpha beta, that is minus 5 into minus 2, that is 10, correct. So now you got clear about this concept, how the coefficient of the polynomial is related with the zeros of the polynomial. Okay, now we can go through the cubic polynomials. Okay,